Hey everyone, thanks for joining. So for that Khronos sponsored talk about the intersection between XR and 5G. Welcome.
Hello, my name is Mauricio Aracena. I work at Ericsson. My main role is to make 5G more friendly to XR, and at the same time, and look at XR use cases that can be used in 5G. So basically, what I'm trying to do is to create an ecosystem friendly for XR, to enable to improve the quality of XR using 5G.
And I'm Fred, XR lead at Collabora. This is my main affiliation. So XR lead, meaning leading a very nice and talented team of XR engineers for customer projects, and also trying to align on the most strategic side of things, aligning our R&D projects on the market trend that I see coming. I'm also outreach officer at Khronos Group, and there, working with the marketing team on super cool projects, trying to outreach to other potential customers, and then spread the word about OpenXR and its benefits. And I will be taking from here. So where are we, right? So we're talking about the intersection of XR and 5G, but where we are right now for what might require some streaming. So of course, as you know, the XR market is expanding rapidly towards the enterprise sector, mostly where we are, getting our new expectations raised. So, photorealistic graphics, super challenging, high resolutions, FPS, object tracking is more and more in demand. Scene understanding is something that we see. Most of the use cases that we're going to be seeing are latency critical as well, and true mobility and the ability to move from one network to the next is something important as well. And so that comes with new challenges. And the form factor that we use being more lightweight and more lightweight, of course, there is some problems with power consumption. I forgot to write it here. So power consumption becomes a thing, and of course, there is much less, compute power on those light form factor, and that's a challenge that we're going to be addressing. And so, because of that, it's becoming more and more important to think about solutions that can actually offload, right? Offload the task that usually were on the client device and offload that to distant servers. And here's a list of actual, real use cases, but also other ones that are more at the research stage. And I will go through the list like real quick, just to make sure that we know what we're talking about. And so the first one is the very typical gaming, cloud gaming. So you have a server, distant server on the cloud that usually renders the frame, where the app runs, and then the frames just get sent downstream to the local client device. I'm going to go to the industrial remote assistance now. So this is a really typical scenario that we have right now. So with a remote worker being assisted by someone, taking a look through their eyes in front of the desktop, and this is something that's happening right now. Medical training simulation, telemedicine, telerobotics, and teleoperation, all super latency critical when you have someone that kind of, wants to have like tracking of the head that gets reported on the other side by gimbal camera movements or, actual robot movements or such. And so augmented field operations, anything, augmentation of on field or, that's on defense or other sectors as well. When you have like AR that can be like really well enriched, this is something that we're also looking at. And so taking, all those use cases, they're going to leverage at some point remoting frames. And so this is a little breakdown of what we have right now. This is the more classical, sorry. So the more classical remote rendering as we always hear it, it's a really simple offloading of graphics, from a distant server back to the client, and the client hardware just becomes a big decoder, right? But there's more. Split rendering is something that's happening right now. This is really interesting in the sense that the application or the game that you want to deploy, you deploy it both on the server side and on the client side. And those two, so there's many scenarios, but one scenario is that you deploy the game in server mode, like it runs on server mode, and the exact same game built for the OS for the local headset is going to be running in client mode. And those two parts are going to be talking to each other and coordinating things. Of course, what's happening on the local headset is going to be, typically UX, interactions, audio, triggers, and what's happening on the server side is going to be like heavy lifting of, frames, but also more than we're going to see. And so those more things now, like remoting SLAM, remoting complex tasks, this is what we call the XR compute offloading. So not only offloading frames, frame generation, but more than that. And so this is an example of what we are starting to see get offloaded, right, in such scenarios. So this is the typical rendering scenario where, distant server produces the frames. For some time in the future, that frame goes back to the client device and gets displayed. Awesome. But now we have potential scenarios where, for scalability reason and just very tiny scale form factor of the client devices, we might want to offload their localization algorithms. SLAM is now done on edge in some circumstances, and so what comes back is the location, the CV. Sometimes it's just metadata. And it's a bit like that for the scene understanding scenario, where you see the local device is going to, to send the video, mono stereo, and then the server side will just compute the SLAM, compute the scene understanding, detect all of the planes, surfaces, and markers, and send them back to the local device. And so in a little bit more detail, for what's happening in terms of streams, well, it's a bit like I said, right? You have on the left the device, so what you're typically wearing on your head, and the server is going to do the heavy lifting. In that case, we are asking two things, right? The server is going to be the cloud rendering, so getting the pauses from the wearer's head, producing frames for the game or the application with those pauses, and then sending the application video and audio back to the local device, right? In that case, we have spatial compute. So we are actually asking we're asking the device to send images and video frames of the surroundings so that the server side can actually compute scene understanding or spatial metadata, and then send all that back in pause optimization, point cloud, or such complex metadata back to the device. And that will be it for my part.
Thank you, Frederic. So it's not only about making software, it's also about how you want to deploy a business about that, and you need to look at also the architecture, what actually you want to use. So you have several combinations of whether you have a device that's connected to a PC, a cable, and several other options that are wireless in some way, that you probably you have a side link from the headset towards a phone that connects that one. You may have a home or Wi-Fi enterprise that actually connects to a private cloud, or everything is on premises. Then you can actually have a private 5G for your own and big corporations that have a private cloud. And then you started to scale up to more outdoor scenario where you move from Wi-Fi to public 5G. And then you lose a third-party cloud like AWS or Google Cloud or whatever. And then you may have more advanced services. And then that's something that I want to mention to all of you. That's different type of 5G in the market. The ones that the consumer uses, which is basically mobile broadband, is over OTT. So normally you have a very good bandwidth, but it's always a best effort solution. So for streaming scenarios like XR in real time, those may not fulfill when you want to scale in outdoors or public networks. That's why it exists also differentiated connectivity, something that the service provider can ask operator to buy, and then you get a reliable connectivity. So the ecosystem is actually quite complex because you have the devices that are 5G, devices that are not 5G. Most of them are today like that. And then you have several options of connectivity you need to deal with. as well as what sort of how you wanted to actually accelerate the functionality, what sort of cloud infrastructure you want to achieve. And then you have like service provider, the one who actually offers the service or write the application, needs to think about all these scenarios. I'm pretty sure that some platform provider with XR services need to deal with it on a daily basis. And depending on their customer, they need to see what sort of infrastructure is best for that. But that imposes a challenge how actually you solve your streaming services. So, first of all, there are a lot of challenges that we try to address here, and we try to solve it in a way. First of all, let me go for it. So first, there's many ways to offload the application. Either you partially offload some functionality, like GPU-intensive tasks, or you want to offload entirely the application into the cloud. You have benefits on that because basically the battery on your device is going to be completely safe because you run the entire application in the cloud. But then, of course, offloading imposes connectivity challenge requirements. Basically, as Frederic explained, most of the content is video real-time encoding. You have to deal with traffic management of multimodality sort of information like audio, video, pose, and you need to synchronize them. So you need to actually think about how to send that to the cloud and the device. Then you have latency variations in the network, you need to deal with that. And on top of that, you need to actually have some sort of a protocol to manage the session establishing between the client and the server. Well, the good news, it's 5G and cloud can be configured for that. However, you have to understand that if you go for a scale and you have location-based service, or you go to a stadium and you want to actually stream that, you actually need to go for a more reliable connectivity, and that basically means extra pay 5G connectivity. You can do it by SLA, by subscription, and then you probably need to add some network code there that is related to the 5G, which is something that also imposes challenge for developers, which normally we call it network APIs. But then, how we simplify all these challenges to scale and to deploy services and make it simple? Well, and also we want to add that we should not forget Wi-Fi is also important. So 5G and Wi-Fi need to coexist in the way how you develop your service. And the evolution of connectivity, it's going to change. So you need to probably update your code when you actually connect between the server and the cloud. You need to probably use new network management, handle traffic, and so on. So you need to keep updating that, and that's also a challenge to maintain the service. That's why we are proposing to standardize some sort of API that deals with the connectivity. There are solutions already in the market. You can see the list of them. There are quite many. They also use sort of the same idea behind there. You encode video, you have a protocol, you establish a session. But basically, for developer point of view, you need to adapt to all these solutions, and there are all some solutions that are tied to a device. So there's a slow down development cycle, time to market, and then you are constrained to probably one particular solution. So what we try to propose here is that provide a common framework how to offload XR applications and functions, and define offloading functionality API, a very high-level API that doesn't require connectivity knowledge, network management or whatever, so our network agnostic that can work in Wi-Fi, 5G, cable, and so on. Khronos is a nice place to actually work on the standardization because have APIs, define the API specification, and then the implementation led for the person who actually implement them. It's not something that you deal about how you implement, but it's important to standardize there. So all the solutions that follow the same idea will be easy. So if you actually move to a solution, you just recompile the code, but you don't need to change the code. So that's the idea. So when Frederic presented the paradigm of loading, the streaming API is basically on top of those components. So you need to have a rate control, the handle network management, a median code to encode the information. You cannot just send raw video data into a network because you will kill whatever you have. But also deal with latency changes and so on. So our proposal is that streaming APIs act as a high-level socket. You just input raw video, raw data, the media data that you want to exchange between the server and the cloud, and then the API will take care of session management, network traffic characteristic, and also encoding. So when I show about these deployment scenarios and the problem with good faith, the streaming API basically will hide that sort of complexity. if everyone agree on this streaming API, basically the development of how you scale or how you evolve from a very simple connection from a Tether device to a Wi-Fi home network, private connectivity in the premises of the enterprise, you can easily scale step by step. You don't change the code, you just change the infrastructure, because the streaming API will hide that complexity. And that's the value of standardizing this API. So a little bit about how we wanted to use this API. So then the first, to the left, you have a device that have an application and run a heavy XR application, and this is no offloading at all. And basically interact the hardware, that could be the runtime of the XR, of the device, and so on, and run it like that. And then, for instance, you have an option that is quite in the market today, which Cloud XR, for instance, that you basically accelerate GPU functionality. So you have a sort of a plugin that probably works with the game engine instead of the application. So you offload the heavy parts, and then you have a sort of SIM plugin. But the API, it's basically the concept of just establishing the communication. Another option will be that you develop a sort of virtual runtime or virtual hardware or virtual platform in the cloud, and then you basically started to reuse the entire code that you develop, and then you communicate using a thin client that interacts with the local hardware. And the API will be the same, establish the session, encode it, and so on. However, you may limit it for some particular functionality because the sync client may not have access completely to the full hardware capabilities, because that's up to the OEM to expose what you can use. Another option will be like even more low-level integration, for instance, a runtime level or a hardware level, that basically the OEM implement the virtual driver or virtual runtime in the cloud, and they integrate the API. So basically, when you want to compile the code for a cloud version, you just ask the SDK of the runtime vendor to do it, and then you just reuse the code as it is. And then you have full functionality exposed by the hardware vendor what to use. And that will enable for you to have a common framework how to develop that. And it's independent of the connectivity. You just have the code, and the life cycle of the software development is the same. So what comes next? So first of all, we are, as an Ericsson company, we try to promote and do a lot about how people can use 5G, and do a lot of experiments. We can guarantee that the 5G can be configured to fulfill your requirements. We run a lot of experiments about actually offloading special compute. It works, and I can tell you that saves a lot of battery in the device, so you can have a scale of hours extra by just running the same use cases when you actually offload. We are working in Khronos to try to incorporate those ideas with a standardized API. We are working with a demo with, which we'll call Extreme API to Monado, which is, our version of the API is Extreme, is called. It's basically the same drawing that Frederic showed and I've been showing, and we are going to open source that one, so you can actually use and play with yourself.
Yeah, thanks. And Collabora, anyway, is spending R&D budget all year round on meaningful projects like Electric Maple. That is kind of new. It's an OpenXR streamer based on Monado and GStreamer. You can check it out. It's open source, it's free, and it's starting to be really something. Split rendering extension for Monado maybe coming next. Why not? But anyway, we are, without being able to say much, we are all as Khronos members trying to push for new extensions and new cool features among the working groups, and try to see what we can do as extensions to the Khronos standards. And that is about it. Thank you very much, everyone. If you are interested in OpenXR standardization, you have ideas, you have feedback, you have anything, right? Get in touch, right? We would love to hear from you. It's always something that's very important. We want to hear from the community. We want to hear from the developers. And so do not hesitate to reach us through the common links here. And thank you very much for your attention.
Do you have any questions? Or do you have maybe a minute or two for questions?
Over there.
Thank you so much. Maria Gorlatova, Duke University. Fantastic talk. Very, very helpful. I hope this isn't too much of out of the left field. But what about the monetization of this? So let's say that you're an XR app developer that is building things that rely on these advanced 5G capabilities. So you want an XR app that relies on rendering that is supported by 5G. How would you pay for that? Like, do you, as an XR developer, I want to sell an app, but here it seems that I cannot just sell an app, right? I have to sell an app and some kind of a subscription service. How does that work? I hope this is not too out of scope. Tell me if it is.
No, it's a good question. It's going to take a long time to answer, but depends. If you sell the application, you will probably recommend to let's look at an enterprise perspective. Then you will have to deal with them to tell you, okay, if you want to, depending on how you want to coverage for that, you need to talk to the operators. There are other brokers, companies like Vonage in Ericsson that deal with talking to different operators, so you get sort of differential connectivity brokered, and then you get it directly. And there's a very simple SLA that is going to be in place. So that's the simple answer. But depending how you want to run your business, you could negotiate that directly to the Vonage or the broker or the CSP directly. There are many ways to do that, but that's an ecosystem question for banking business.
Okay, a round of applause. Thank you so much again for your time.